Okay, so let's go ahead and put your math knowledge and skills to work on this interesting math word problem. Matter of fact, let me go ahead and read the problem here. It is the following. A race car going 150 miles per hour went around a circular track in 5 minutes. How wide is the track? Okay, so I don't want to give you any hints here because I want to give you a full opportunity to show off your math skills and abilities. By the way, feel free to use a calculator, but if you have your answer, go ahead and put that into the comment section. I'll show you the correct answer in just 1 second. Then I'm going to walk through the solution to this problem in three distinctive phases. Okay, and each one of these phases are very important to just overall general mathematics. Okay, I guess I would classify a lot of what I'm going to be talking about as practical math skills. Okay, so if you're a little bit lost here, if you stick with me for a few minutes, you'll totally understand how to solve a problem like this. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if you like this video, or if you enjoy it, or if it's just helpful, make sure to hit that like button and that subscribe button, as that definitely helps me out. Okay, so let's go ahead and take a look at the answer here. The answer is approximately 3.98 miles. Now, let's make sure we understand the question. The question is, how wide is this circular track? And it's approximately 3.98 miles. Now, if you have an answer that is close to 4, right, I'll accept that because this is a pretty rough approximation, and you'll understand why it is a rough approximation when I get to that part of the solution. But if you have a decimal somewhere pretty close to this, well, that's a good indication that you figured this problem out. And we've got to celebrate by giving you a nice, slow, happy face, an A plus, a 100%. This is the favorite part of being a math teacher. So you just kind of like, reward people. And I got to throw in some stars here so you can brag to your friends and family that indeed you are a certified professional expert in the area of, well, let's go ahead and break down the phases in this problem. Now, I did say three distinctive phases, right? So the first phase is going to be converting units of measure, okay? The second phase is going to be finding the circumference. And the third phase is actually doing a rate times time distance problem. And I think I got those phases in order, but those are the three things I'm going to be talking about. But anyways, if you were able to do that or do this problem and get this problem correct, well, that's very, very good. And for those of you that are like, I'm so sad because I don't understand what's going on, this is not that difficult. All right. If you stick with me for a few minutes, you'll be looking like this person. So let's go ahead and get started right now. All right, so as in any problem, okay, math word problem, but I would suggest any problem anywhere, you got to thoroughly understand the problem. So just don't read the problem and be like, okay, I'm ready to go. I like to use the rule of three. Read the problem at least 3 times. So first time, just kind of get a sense. You're like, all right, I got this race car going pretty fast around a circular round track, right, in 5 minutes. How wide is the track? So once you really, have a full understanding of the problem, what you want to do is model the problem. Okay, you want to visualize the problem, and this is a good candidate to do, or this problem is a good candidate to visualize it. Now, some math word problems, it's not so easy to kind of construct a graph or a sketch of what's going on. But here, clearly, we can come up with a basic sketch of the problem. So basically, you don't have to have a perfect sketch, but what you want to do is draw yourself a round circle, right? We do have a circular track here, meaning that the track the race car is going around is a circle. All right, so we have our car right here. It's going 150 miles per hour, and it was able to do one lap, right? So let's go over here. So a race car going 150 miles per hour went around. Okay, so that implies that it went around this circular track once in 5 minutes. Okay, so we kind of have to interpret that, right? So it's going 150 miles per hour, this car here, and in 5 minutes it did one lap. And the question is, how wide is this circular track? All right, now because we are talking about a circle, it's going to be a good idea to know a little bit about circles to solve this problem. But that's not the only thing here, right? We kind of have to have a strategy like, well, how can we get this width here of this circle with just this information? Because this is the only information we have here, right? So if we go back to our problem, the only thing that I have is that this car is going 150 miles per hour around this circular track in 5 minutes. So it's obvious that I'm going to have use this information to figure out the actual solution. Okay, so how can I do that? Well, let's go ahead and take a look at this problem a little bit more in depth, but let's start using the language of circles. All right, so the width of a circle, or how wide the circular track is really implying what is the diameter of this track, or what's the diameter of this circle. The diameter is the width of a circle. So being that we're talking about circles, so you have a circle, the width of the circle is the diameter, and it runs to the center of the circle. One half of the diameter is something called the radius, okay? All right, so just basic terminology for circles, but this is what we need to do, right? We need to find the diameter of this circle. But when I'm thinking about this, I'm like, well, the only information I have is the speed and the time it took this car to travel around this circle. Well, I could use this information right here to determine the distance this actually is, right? So if the car it was stayed at this speed 150 miles per hour for 5 minutes, I could actually calculate the distance around this circle one time, all right? And that is what we call the circumference of a circle. So if I could get this circumference, right, well, that's enough information for me to actually get the diameter, right? And of course, I'm going to show you exactly how that works. So we need a strategy. We need some sort of basic steps here. So step one is we're going to find the circumference of the circle, all right, which is the distance around the circle. Okay, and I could do that by using this information right here. Of course, I'll show you how we're going to use this information to get the circumference. But once I have the circumference, the second step is I'm going to use that circumference information to find the diameter. Now, both of these steps here are going to require formulas. Okay, some basic formulas. Matter of fact, I'm going to write the formula down here, formulas, excuse me, and I'm not going to tell you what they mean, but if you're like, okay, I get it, I just forgot the formulas, well, let me give you the formulas here because you might want to pause the video and see if you can figure this thing out. All right, so for this first part, to find the circumference, you're going to need this formula right here. Rate times time is equal to distance. Okay, that's the first formula that you need. And then here, to find the circumference, you'll need this formula right here. The circumference is equal to the diameter times pi. Okay, now of course I'm going to explain how these formulas work. And there's a bit of a twist on this part right here. But, hey, I want to give you an opportunity to be like, oh, I got it, I got it. Well, then continue, run with it, right? See if you can figure it out. I did give you the answer. But let's go ahead and get started now. And we're going to first find the circumference of that circle. All right, so the circumference of the circle is effectively the answer to this question, okay? And that is, how much distance does the car travel in one lap, right? So that car going 150 miles per hour, for 5 minutes does one lap. How much distance is that, right? Now the distance it uses, it doesn't make a difference if it's going 150 miles an hour for 5 minutes this way or 150 miles an hour for 5 minutes this way. It's the same distance, okay? In other words, if you took a string and you kind of wrapped it around a circle, that's the circumference. But you could take that string and then just kind of straighten it out and just kind of measure that distance in a straight line. Okay, it's the same distance. So this formula here is one of the most practical formulas that I think everyone wants to kind of put into a practical math toolbox, all right? And it is the following. Rate times time is equal to distance. Rate times time is equal to distance. And let me give you a simple example. All right, so let's suppose we have a car. That car is going 60 miles per hour. Now, this is a real simple example, but let's just kind of, understand this, right? 60 miles per hour. So this is rate, okay? A rate of something is the speed or velocity of something, okay? So for cars, for example, here in the United States, we use miles per hour. All right, so a car is going 60 miles per hour, and let's suppose this car traveled for 1 hour. Now, if I told you a car going 60 miles per 1 hour, how much distance did it go? Well, hopefully it's obvious that the car went 60 miles. But let's suppose it wasn't obvious. We can still use this formula here. So 60 miles per hour times 1 hour is 60 miles. 60 times 1 is 60 miles. Now, I want you to kind of really pay close attention here because the units of measure are tremendously important. Okay, so if we have our speed in miles per hour, notice here our miles, this is how we measure distance, and time, we're measuring it by hours, okay? So really 60 miles per hour, let me actually erase this here because this is a teachable moment and I don't want you to miss anything. All right, so right here, 60 miles per hour. This is what we call a rate in mathematics, but you can express this as a fraction. 60 miles, okay, per, that fraction bar, P is this fraction, per is this fraction bar. And the H is 1 hour, meaning the car is going 60 miles per 1 hour. That is the rate of a vehicle. A rate in mathematics is effectively a fraction that compares two different units of measure. All right, so not to get overly technical, but again, this is all really important stuff. Okay, so here we have 60 miles per hour. Again, we're measuring distance in miles and our time in hours. So therefore, to figure a problem out, if we have 60 miles per hour being our unit of measure for speed or our rate, then we have to have the same units of measure for time and distance. So for example, we need to measure our time in hours and our distance will be in miles, okay? And this is going to impact what we need to do right here. But let me just show you this right here, miles per hour, and how this kind of units of measure cross cancels here. So this again is very important. So miles per hour. So this is miles, okay, per hour. Let me just kind of put the hours right here. And if you don't understand this, well, not a big deal for now, but this is important. Okay, so this is miles per hour, and we're multiplying it by hours. Okay, hours just over 1, or there's no miles per hour, it's just hours. So that's hours over 1, and that's going to be equal to, well, it's going to be equal to miles. But why just miles? Well, because you can see here the units of measure, we have hours in the denominator and hours in the numerators. When we multiply, these units of measure cross cancel, and that's why our unit of measure here is miles. Okay, and this is important because this is how we convert units of measure. This is extremely, extremely important in many areas of practical mathematics. Okay, so let's go ahead and actually see how this is done. So here is our lovely formula, rate times time is equal to distance. So we know the rate of the car, it's 150 miles per hour, and we know the time at the cars, traveled, that's 5 minutes. Okay, it went 5 minutes. But listen, I need hours. I can't use 5 minutes here, so I'm going to have to convert minutes to hours. Okay, so how do we do that? Well, this is pretty easy. So 5 minutes equals how many hours? Well, what we want to do is use a conversion factor. So most of you could be like, well, just don't we divide by 60? Yes, that is correct. But let's just kind of break this down nice and easy here. Okay. So a conversion factor in mathematics is something that equates two different units of measure. Okay. So for example, 1 hour is to 60 minutes. So 1 hour is 60 minutes. Okay. Or 60 minutes is to 1 hour, okay? Now, both of these are correct, but which one do we use here, okay? Well, what we need to do is take our minutes and multiply it by a conversion factor, all right? And the conversion factors that we can choose from is either this one or this one, something that converts minutes or equates hours and minutes, okay? But specifically, I have to use this one, okay? Not this one. If you use this one, you'll make a mistake, all right? Things will not work out. So why is that? Well, because we're looking to cross-cancel the correct units of measure, all right? So let's go ahead and see how this works. So 5 minutes times 1 hour over 60 minutes. So this is a fraction. I should put that over 1. Now you can see that the minutes are going to cross cancel right here, okay? And remember, I'm trying to get rid of minutes and be left with hours. So this, if I have minutes in the numerator here, I need minutes in the denominator. So if you're confused about conversion factors, just set up your fractions such that the units of measure you want to go away from, cross cancel, and you're left with the units of measure that you want to go to. All right, so we want to go from minutes to hours. You can see our minutes are going to cross cancel. So this is going to be 5 times 1 over 60, or that's going to be our fraction 5 over 60. And of course, I can reduce that fraction to the fraction 1 over 12, and we're left with the units of measure of hours. Okay, so this is 1/12 of an hour. So 5 minutes is 1/12 of an hour. Now, a lot of you might say, boy, Mr. YouTube Math Man, that's a long-winded explanation. Well, listen, I've been doing this for decades and decades, and I only emphasize things that I know most students, have, I knew it. I knew it. I'm trying to think of a funny type of phrase, but I really can't come to mind. But basically, if I had a nickel for every time I heard this phrase, I knew that, I knew that, I knew that. Well, if you knew that, why didn't you do that on a test or exam? So again, converting units of measures is one of these things that students think they know better than they actually do. Okay, so if you really thoroughly understand the breakdown of what I'm saying here, it's going to help you out big time. Okay, so now let's put this all together now, and let's go up here. So remember, we have rate times time is equal to distance. I have my rate in miles per hour, therefore I need my time in hours, but I had 5 minutes, so we converted 5 minutes to hours, which of course that is now 1/12 of an hour. Now we could put this all together. So in our answer, okay, is going to be in miles. I have miles per hour, hours here, so our final distance will be in miles. All right, so let's go ahead and do this math. So this is going to be 50, that's our rate, right? Times 1/12. And we can kind of drop the units of measure here because we know the final units of measure is going to be in miles. So that's going to be 50 over 1 times 1 over 12, or 50 divided by 12. Yeah, again, you can use your calculator. That's 12.5, but 12.5 what? 12.5 miles. Okay, so what did we just calculate? Well, we just calculated the circumference of that circle, right? So here is where our problem stands. Okay. So we determine by using the rate times time is equal to distance formula. Okay, we had this information here. We determined the distance it takes, or the distance the car traveled in one lap around this circular trap, and by definition, that is the circumference. So the circumference of the circle is 12.5 miles. Okay, so that's awesome, but now we need to move on to step or the final phase here, because really there was two phases to get this piece of information here. We had to convert the unit of 5 minutes into hours, and then we had to apply this in the rate times time is equal to distance phase. So now we're finally ready for the finale to actually get the diameter. Okay, so let's go ahead and take that step. But before we do, I'm going to ask you to take the step to subscribe to my YouTube channel. I wouldn't ask you if it wasn't that important. Okay, yes, it's important to me personally, but my objective is to reach as many people as I possibly can. Okay, because the worst thing that I've seen, I don't want to say the worst thing, but one of the things that I definitely want to try to stop in this whole idea behind my YouTube channel is people giving up on mathematics. I've seen this time and time and time again throughout my life is people, they'll come, they'll be my students sometime later in life, but they'll be like, well, I just gave up, some bad or some math teacher, told me I was bad at math or I failed math and now I think I never thought I was smart in math. Listen, if I'm talking about you, okay, well, I'm telling you right now, do not believe, don't believe yourself, all right? All the things we tell ourselves, probably 99% of it is not true, okay? Especially if it's negative self-talk. If you want to be successful in math, you absolutely can, but you need great math instruction, clear and understandable, and then you gotta be willing to put in the work, okay? So there are no shortcuts, so you could definitely be successful, but you gotta put in the work. But anyways, by you subscribing, it does help me find those folks that need my help. And make sure to subscribe as well so you can get my latest videos. Okay, so thank you so much for listening to my little pitch here. Now let's go ahead and finish this problem up. Okay, so here is the situation. We have our circle. We know the circumference of that circle is 12.5 miles. That's the distance around our circular track, right? And the question is how wide the track, okay? How wide is the track? Of course, that is the width of the circle, or by definition, the diameter. So now what we're going to need is a formula that relates the circumference and the diameter. And lucky for us, we have a formula like that. And this, again, uh, our formulas, the things that I'm talking about here, these are formulas that I would encourage most of you out there to put into your long-term memory. These are things that, even if you forgot them, that's fine. But if you're going to remember any formulas in math, these are kind of basic level formulas that you should, try to commit to long-term memory. Okay, there's a lot of information in math, and you don't want to try to learn, use rote, R-O-T-E memorization. That's just like, old school flashcard memory to memorize everything. But this stuff that I'm talking about here, I would think that most people should, kind of be familiar with this stuff. Okay. Anyways, but if you forgot, the circumference of a circle is equal to the diameter times pi, or there's another version of that. Circumference is equal to 2 pi r. So what is pi? Okay, this symbol here. Well, this symbol, pi, represents a number. It is one of the most important numbers of all mathematics. Matter of fact, I'm going to give you a micro lesson on pi. If you take any single circle and you divide the circumference by the diameter of a circle, any circle, right? You take the circumference divided by the diameter, you're going to get this lovely number. It's around 3.14, on and on and on. This decimal, okay, is what we call an irrational number. It's a non-repeating, non-terminating decimal. It goes on to infinity. Okay, so instead of writing out this infinitely long decimal, we just come up with a nice symbol for it called pi. It is, again, the most, I would say, yes, it's right up there. It probably is one of the most important values in all of mathematics. Now, here's the deal, okay? Because it's an what we call an irrational number, this is a long decimal that never stops, I am going to use, for the purposes of this problem, the decimal 3.14, which is the most basic estimation for pi that you would ever want to use. You wouldn't want to use anything less than 3.14. So that's why I indicated in the beginning of this problem that if you got an answer that was a little different than mine, well, it was probably because maybe you used more digits of pi, which was, fantastic. That means your answer is more accurate than mine. So the more digits of pi that you use, the more accurate your answer is going to be. But for just the purposes of this problem, we're going to keep it simple. Just use 3.14. And by the way, if you're thinking, well, how can I get these digits? Where is this at? You could pull this up on your calculator. Sorry, if you have some sort of scientific calculator, you could pull up the value of pi for the digits, for how many digits can be displayed on your particular calculator. Okay, so that's what pi is, and it's important that you understand that, because now we need to apply this information. So we want to solve for the diameter, okay? So let's talk about what information we have. Well, we have the circumference of the circle, right? We already figured that out. That's the distance around the lap. We know what pi is. Pi is just a number. I want the diameter, okay? So I'm going to use this formula, not this formula. 2 times r, 2 times the radius, is the diameter. So it's basically the same formula, but we're going to use this formula. And what we need to do is solve for d. So d is the diameter. So I can look at this formula this way. The circumference is equal to the diameter times pi. If I want to solve for the diameter, I could just simply divide both sides of the equation here by pi. So the circumference divided by pi will give me the diameter. Okay, so finally, we can actually solve this problem. So the diameter is going to be approximately, remember in mathematics, this equal sign means that's the exact, precise, equal, it's the exact answer, okay? So when you don't have the exact answer, because we are approximating pi, you need to change that equal sign to this little double squiggly thing here. That means approximately. Okay, so that's an important little detail there. So we're going to take our 12.5, okay, that is our circumference, right? 12.5, and we're going to divide it by pi, which is approximately 3.14. And when we do that, we're going to get 3.98 miles. Now, again, if you used a more accurate estimation of pi, you would get a more accurate answer. But that is the diameter, i.e. the width of our circular track. Okay. Now, if you look like this, you're just like, you know, man, I got so much smoke coming out of my ears. I don't know where to start. Well, listen, I did kind of throw a lot of information here, but it's nothing beyond your ability to learn. Okay, and I'm very sincere when I, talk in that manner. Okay, maybe it's my own personal, experiences in life, but yeah, my attitude towards learning anything is, failure is not an option. You can learn something, all right? Once you determine, make up your mind, all right, I'm going to learn this. If you have that kind of attitude, that's 90% of it, okay? But, once you have a great attitude, what you need is not to take shortcuts. You need great instruction, comprehensive instruction. Then you got to practice, 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 and eventually you are going to be a certified professional expert mathematician, right? Now, if you want to learn math, or if you're just kind of starting off, let me give you a couple of quick suggestions. One, I have a ton of additional basic videos on my YouTube channel that you can check out. But kind of the order that you want to go is kind of review your basic math skills first. So I have a great little mini course called my Math Foundations course. There's the links to all these courses will be in the description of this video, but that's like a basic review of arithmetic and basic math skills. Make sure you get the basics down and then move on. Okay, start with algebra, start with pre-algebra, then algebra 1, geometry, algebra 2, and then you kind of move into from there, you can go into pre-calculus. You'll find all those courses there. Pre-calculus includes trigonometry as well. And you go through all of that, then you're pretty much ready to get into a full calculus course in college, right? And create the new exciting, technology of the future. Okay, so with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.